Engineering, or IEEE, student branch of University of Mortua, with partnership provided by the IEEE Signal Processing Society. The first session was held the previous month with guest speaker Mr. Kitmin Wickramasinghe, who shared his valuable insight and experiences about undergraduate studies and extracurricular activities. Continuing with the brilliant success of that session, we now commence the second session of SPS Echo to provide you a stronger vision regarding your academic career and future opportunities. Our guest speaker for today is a research scientist with Amazon Research and a PhD candidate at the University of Maryland, United States of America. His research interests are diverse, including computer vision, machine learning, and natural language processing. He graduated from the University of Mortua in 2018 with a first class honors Bachelor of Science in Engineering from the Department of Electronic and Telecommunication Engineering and has been involved in numerous publications. He also has academic accolades in other areas of study, such as information technology and law. To share his ideas regarding the title, Stepping into Signal Processing and Machine Learning Research, I would like to cordially invite Mr. Vinoj Jayasundara to address the session.
Well, thank you very much, Oshan, for the very kind introduction, and thank you very much for inviting me for this session today. Um, I'm going to share my screen. Um, uh, do I have permission to share screen, Oshan?
Yes, I think you should. Can the OC check into whether he can share his screen?
Okay, I think I'm able to share my screen. Um, all right. I hope you can see.
Yes, you are.
Sure. So, today, we are going to talk a little bit about stepping into signal processing and machine learning or deep learning research. So today's session is going to be, let me turn off this. Okay. Today's session is going to be mainly two parts. First, we are going to talk a little bit about some of the exciting developments in the fields, and then why these areas are very important to us, how to get started with these fields, and then we will have a brief Q&A session afterwards. And during the second part of today's session, we will focus more on how to do good research, um, what are the tips and tricks, do's and don'ts, and these kind of things. And then let's again dive into some Q&A afterwards. So one of the most interesting things to me in machine learning and deep learning these days is called DALI 2. It's a brilliant research project where you can imagine anything. You can just type in the text description of anything that never exists before. For example, you can see that a bowl of soup that looks like a portal to another dimension, portrayed as some digital art, and you can see the system rendering these things out. So this is some exciting thing that's going on these days. Um, so another thing is GitHub Copilot. Some of you might have already seen this. So what this does is once you give a suggestion that you want to um, write a certain piece of code, this system will automatically generate that piece of code for you, uh, basing on some of the code snippets that it has seen. I mean, GitHub has like thousands and millions of code snippets for probably the same thing. So GitHub Copilot is a nice way of automating some of these code writing tasks for you. So that is some other exciting development in machine learning that we see these days. Um, one more about deep learning and computer vision, image to image translation. You can kind of see that in the first image that you have to the top left, you see a painting by Monet, and you see that this painting is now being converted to an actual image. So image to image translation is just transferring the style of an image or some characteristics of an image. So for example, in the second one, you can see that um, an image of two zebras being converted into an image of two horses. And then in the third one, you can see that the season in which the photograph was taken is being changed, like from summer to winter and vice versa. So essentially, you can do style transfer sort of things, as you can see at the bottom. You can take a photograph and you can um, change the style into Monet style or Van Gogh style or Cezanne style or any style you want. So this is a very interesting thing. So you can essentially take a photograph and change basically whether it was taken on a rainy day. You can change it to a sunny day. You can do all sorts of things. Another very interesting signal processing application is how to see people from behind walls. Now, this is a bit of a like a you might even say this is a bit ethically controversial, but still, this is a very cool project. So they use Wi-Fi radio signals, and they accurately try to show what happens to this person once the person goes behind the wall. You can see that this person's pose is still being tracked, even if the camera is unable to visually track this person. So there are very interesting things happening in signal processing, machine learning, and these days. Yeah, these were some of the examples that I would like to share. So now, why should someone get into these kind of research, especially in signal processing, machine learning, or deep learning? So these areas are buzzing these days all over academia and industry. So because these things are buzzing and it has so much potential, you have plenty of opportunities throughout for these areas. So once you build a very strong research performance, it can open a lot of doors for you. It can give you a lot of opportunities. And once you have very strong research performance, that's actually one surefire way of getting a graduate degree admission. Whether you want to be a research scientist or whether you want to join faculty someday, having a strong research profile in signal processing, machine learning, and deep learning is going to help you dearly. And not to mention that big companies or the big universities throughout the world is going to pay you handsomely for your skills in these areas. And I have um, a small snap here from AI Pay Grades. Some of you might be very familiar with this. AI Pay Grades is uh, a website that maintains salaries. These are like close to actual salaries of people, scientists and engineers working on AI companies. So you can see that actually annually, uh, overall, you can kind of earn close to $500,000 before taxes. Now, you might ask, are these numbers real and can people actually make these numbers? When you join companies like Facebook, Google, Amazon, yes, you can actually, these are like very realistic. These are some of the numbers that you can actually make. So I mean, it's a good motivating factor for you to get into signal processing, machine learning, deep learning, and some of the related areas, even data science as well. So it's very highly sought these skills throughout the world. So it's a good motivating factor to get into this field. And of course, even if you're not directly related to these fields, and if you're not directly doing research in these fields, because signal processing, machine learning, and deep learning has so many applications across every domain almost, whatever the domain that you can think of, even even like whatever the subject area that you can think of, physics, chemistry, biology, or anything has they have ample applications in those areas. And these things are not becoming like a uh, thing that you can help to do your tasks anymore. Now they are becoming more like must-know tools that you have to kind of know, even if you want to do something in those different domains. And of course, another good thing is that from even from the projects that we kind of saw, which are very recent research projects, they are very cool, and it's highly satisfying to work on some of these things. So moving on, we have now some of you might ask now, the previous slide was mostly for people who would like to join faculty or people who would like to join industry as scientists, research scientists, or mainly researchers. But what if you want to become an engineer or an entrepreneur? So why do you have to care about research so much if these are my goals? Actually, if you are an engineer, if you are, or if you plan to become an entrepreneur someday, actually you have to pay as equally as equal attention as those who want to become a scientist and join faculty, because a lot of industries these days, they deploy products, they make products, and they deploy products, and these products are based on the cutting edge research that scientists do. Usually what happens is, even from my time at Amazon, what I've realized is that engineers pay special attention to recent um, publications and recent developments in the research areas, and they try to incorporate them into their production pipelines and in their tools and um, in their developments. So here is one example of that. You might have already seen this. So this is Google Pixel. So Google Pixel is using this magic erasing tool, um, which is a development, which is a recent development in the computer vision and deep learning area. So, and once the scientists do these things, it doesn't matter if the scientist is actually from Google or from somewhere else. Most of these research are published openly. So the science team of any company is working very closely with the engineering team, and then the engineering team then takes these ideas, take these models, and take these techniques, and they deploy into the real world. So there's one other thing called Amazon Alexa. So there are some developments in audio signal processing areas, and now they're trying to incorporate this into Amazon Alexa to mimic the voice of any person that is in the house. And this can include a deceased person as well. So if a person wants to, if the family members would like to hear the voice of a deceased family member, then they can use this feature as well. So this is still not out there yet, but the engineering team is working on this. So this is another very good example why the engineers or those who want to become engineers uh, um, should follow research very carefully. And even if you want to run your own business someday, you have to keep up with the recent developments. For example, if you are in the business of um, creating devices like Alex, or if you are in the business of creating or like producing smartphones, then your smartphones or your voice assistant devices should have these capabilities that the other competitors do, because the competitors, especially these big companies, they definitely follow the latest research and they try to incorporate them in their products. So if you don't try to do that yourself, then you kind of will be kicked out of the race for that product, unfortunately. So even if you want to become an engineer or an entrepreneur, it's very important that you learn how to do research and learn how to follow up research. Right. So we talked about the importance of uh, signal processing, machine learning, and deep learning research. Now let's get into how to actually uh, do signal processing, machine learning, and deep research. Now, this is something that I would like to call my golden triangle of research. especially for signal processing, machine learning, and deep learning. So this getting into research comprises of three different areas: coding, literature, and theory. So you can't actually get into research without any of these things. You can't just know some theory and get into research. You can't just know the literature and get in. Or just because you know coding, you can't get into research. You have to have a good balance between all these three things. So just to explain, I'll get into some of these details a little bit later as well. But theory is the theoretical component of machine learning, statistics, the linear algebra, the calculus, the probability concepts that you need, and also the general machine learning, deep learning, and signal processing uh, concepts that you need um, to do research. So you have to be well versed in your theory. And also, you should be able to code up uh, the ideas that you come up with. That's a crucial part of research. You have to be able to simulate and prove your theories, your whatever the hypothesis that you come up with. So you should be able to take someone else's work. You should be able to replicate it, or you should be able to make it work on your own, and you should be able to build on top of that. And also, you should be highly familiar with the recent literature. So we'll talk about these three things in a moment. So let's first talk about theory a bit. So the most important question is, how do we find out the resources? Now, there are plenty of courses available. I'm sure that in a lot of um, the university courses, even in the ENTC at University of Moldova, where I learned, I did my undergrad. We had a lot of courses that revolve around signal processing, machine learning, and deep learning, and it provided a very good introduction into the core concepts of these fields. If you feel like if your university does not have what you need, or you need to learn something extra as well, there are plenty of books that you can refer to. The signal processing book by Oppenheim is a classic, and Christopher Bishop's pattern recognition and machine learning book, or Boyd and Vanderberg's convex optimization, and Ian Goodfellow's deep learning. These are some classical books that those who step into machine learning, deep learning, and signal processing research kind of must read. So, and most of these books are available free online, or you can get these books from your local libraries as well, or from your university libraries as well. So these are some good reference points. And also, there are plenty of YouTube courses, open courses, Coursera courses, a lot of things that you can. You should be careful that you pick and learn from the right source. So that's the only thing that you have to be careful of. Otherwise, there are plenty of resources for you to learn. Um, and also the other thing is, some of the best universities in the world, they publish their undergraduate and graduate lectures online. For example, UC Berkeley has published its machine learning, the statistical machine learning course. This is an undergraduate course. Anyone can visit this website, and they can watch the lecture videos. They can look at the assignments. They can look at extra reading material, and you can just follow the courses similar to you were there in UC Berkeley following the course. So, this is one good thing that came off the pandemic, I would say. A lot of universities published their lectures, they uploaded them to YouTube. So even University of Maryland, my university here, has a brilliant course in deep learning and introduction to deep learning. So there are plenty of courses like this from a lot of the universities. So you can refer to these things to learn more about the theories that you need. Um, and then the most important thing is literature. One of the most important things. So Google Scholar, you have to visit Google Scholar almost every day. You have to make it your best friend, and so is archive. So you should try to read literature as much as you can. And when you try to read literature, if you already have a topic in mind, you should read. Of course, you should dive deep into that topic. You should try to learn more and more, and you should try to read papers that are related to that. You should try to read papers who build on top of the work that you're interested in. But at the same time, you should have a good breadth knowledge as well. So that means you should you should not only focus on the topic that you are reading, you should not only stick to the papers on that topic, you should also try to read some other papers that are not may not be even related. Because the thing about signal processing, machine learning, and deep learning is you can draw ideas and intuition from across the field. To solve one problem, the solution might lie on some other place. So, because of that, you should consider reading some unrelated topics, but unrelated topics are papers from unrelated areas as well. So, that is going to help you really. And usually, experienced researchers, sorry, there is a typo there. Experienced researchers, they read usually more than 30 papers a week. Now, when we start in stepping into research, one important question that we all have is where to start, what papers to read, right? And we also mostly won't have any idea of um, um, a research topic or a topic that we're interested in, but we still would like to start some. So in that case, I would suggest starting with some of the milestone papers. So milestone papers are some of the key papers in that. So for example, in machine learning, you have some papers, or even in signal processing as well, you have some papers that we identify as milestone papers. These are some of the key papers that help shape the current standing of that field. So you can know what the milestone papers are for a certain field if you just ask someone who's familiar with the field, or you can refer to some online articles. There are plenty of blogs, plenty of articles written about the milestone papers. You can, for example, read like 25, you can see articles like 25 must read papers in signal processing. You can see articles like that, or 25 must read papers in deep learning. You can see articles like that. So you can refer to these articles and you can kind of understand or figure out what are the milestone papers in this field. So you can start off with these milestone papers. And once you read a couple of them, then you will find an area that's interesting to you. And once you find a couple of areas that are interesting to you, then you can start digging deeper into these areas. So this process will help you not only to know what's out there and to develop your breadth a little bit, it will help you, even if you already have an interested area in mind, this will help you to have an understanding of how the field progressed throughout the years, and you might get exposed to some new areas that you didn't even know that existed. So you might find some even more interesting things than what you were originally planning on working. So definitely reading the milestone papers is a must. And even if you have a research interested area or not, so once you find an interested area by reading the milestone papers, then you can dig deep in, in a few ways. You can still refer to some online articles written about that niche area. For example, if you are more interested in audio signal processing, then you can search for interesting papers in audio signal processing and start reading those. Or you can follow the citations. And this is something that I do when I go to like a very niche area. For example, if you start with audio signal processing and then you go dig in deeper and deeper into some niche areas, once it becomes so niche, you can't even find like blogs or anything written that compiles a list of papers in these areas. So what you do is you find one milestone paper or a baseline paper in this area, and you see the citation, see other papers which have cited this milestone or the key paper, and you start going through them. So this is an effective method especially if the work is recent or if this work is niche. So in any case, if you follow these techniques, then you will find plenty of papers and articles that will help you in understanding the literature. And another very common thing that everybody, even including myself, and I, every time I start researching a new field, this happens to me. So what I read, I don't understand at all. It's like Greek to me. So that's absolutely nothing to worry. This is very typical if you, especially if the field is new to you, even if you have been doing research in some area, for example, machine learning for 5 years, still, if a very novel field comes, if you come across some papers in that area, you might not understand it straight away, which is perfectly fine. So in these instances, in these cases, I have a couple of suggestions for you. So a recent trend of most papers is that they have a project web page. So you can have a look at the project web page, and then the project web page will list down some beautiful examples. They have videos and they have presentations where the researchers themselves explain these things in much more simpler terms than the paper. Or some key papers have videos or articles written about them which simplify these things, with somebody wrote from their own perspectives, and you can understand these things much better than the original paper itself, because the original paper is written in a formal, in a technical sort of a way, but these blogs are and videos are more like informal things that people do for their leisure. So this 2 minute papers is a famous YouTube channel. So that try to summarize these key papers in 2 minutes. They have videos summarizing them. So this is just one type a set of videos, one YouTube channel that does that. But there are plenty of things doing these things. I mean, you don't have to restrict yourself to like 2 minute videos, but there are like very good um, videos and resources out there. So once you go through these things, they will break everything down for you, and you will be able to understand some of the concepts. No, not maybe not all, but some of the core concepts by referring to this external material or material available in the web pages. Now, once you familiarize yourself with these concepts, now you go back, you revisit the paper and you read it through, and most of the time you will have a much better understanding of the paper. So, you can make use of the recent trends that people have project web pages, and the papers have a lot of social media presence these days. So you can make use of these trends. Now, I mentioned that experienced researchers read papers like 30 papers in a week, but I can barely read one paper in a week. But this is totally okay. I mean, no one starts with 30 papers in a week. So you start with like one papers maybe in a week, or you might take 2 weeks to read a paper. But once you get familiarized with that area, you will become basic eventually, definitely. And the way that these researchers read papers is that they don't read everything. They don't read the paper A to Z. They don't read it from abstract to end of the references. That's not how they read. So they read the gist of the paper. They might read the abstract and decide that this paper is not relevant to me. So they might discard the paper right from the abstract itself. Or they might read the abstract, they might read a bit of the introduction, they might read the bit of results and then decide that, okay, I get the idea. I don't really want to know how they did it. I only want to know what they did. So, and then if you realize from reading the abstract part of the introduction and looking at some results that this is actually very interesting and this is something that I would like to do, or this is something I'm generally interested in, then you can dive into the methodology section. You can read a bit more. Of course, if some paper is a baseline paper or if something is directly relevant to what you want to work on, then it makes a lot of sense that you have to read the paper A to Z. But most often than not, we don't read papers end to end. We only read papers to get an idea, or to generally to pick the important ones and to know, keep up to date with the current research. So once another idea comes into mind, then you realize, I read a similar paper like this, so I can revisit, and I can dive deep into that. And another common question is, now, how do I remember what was done in all these papers? You don't have to remember it. No one, I think, um, is capable of like retaining this much information. So what you can do is you can keep a paper reading journal. So I myself keep a journal in Overleaf, and I write all the summaries of the papers, and I keep a reference there. So later, and I organize them by topic, and in a way that's convenient to me. So now, if I want to revisit some of these ideas, or if I want to browse through them, I can just do that, and I will see the summary of the paper. Then I will quickly um, remind myself of the content of the paper. And if the paper is interesting to me at a later date, I can just revisit the paper and then read it more carefully. And of course, there are like plenty of tools out there, like Mendeley or Zotero, that will help you to keep your papers organized, and they have a lot of functionalities. So you can definitely try those things out. So I will have only a few things before we move on to the Q&A session. So I'll quickly go through these things. So um, the last but not the least part of the triangle is coding. As we all know, practice makes perfect. So even if you uh, know all the theories and you're well versed into the literature, there is little use if you can't put it into the practice, if you can't actually code it out and test your hypothesis. No matter how brilliant your hypothesis is, no one is, at least like based on the current trends of machine learning or signal processing, you have to run some experiments and simulations to prove it. I mean, there can be some researchers that don't require simulation. Most often than not, you will need some simulation. So you should be able to code things up. You can use Python or you can use MATLAB, whatever your favorite programming language is. But if when you find an interesting paper and you decide that you might want to like work on this area, or if you're generally interested, it's always a good idea to just play around with it. A lot of recent papers release their code into GitHub. So you can just clone this code and you can just play around. You can try to replicate the results. You can try to make minor adjustments. So getting your hands dirty with coding is actually a must. You can start off with just cloning someone else's repo and just trying to replicate the results, and then trying to do minor adjustments to it, trying to understand the code, and then eventually you can move to a point where you write your own code for the research hypothesis that you have. So one problem that a lot of us have is not having access to hardware, GPUs, or computing resources in general that is required for signal processing or machine learning. So there are like some cloud computing resources freely available to us, such as Google Colab, and AWS actually provides student grants. If you write to them, say that you want to work on a research project, if you write to AWS, they might give you some research grants, some considerable grants. You can use those things. And I know students from undergraduate students from Sri Lanka who have gotten a lot of grants. And you can use the Google Cloud Platform as well. You get some free credits, about $300. So you can make use of these hardware and these resources that's available to you. And apart from these three things, these core three things that you must perfect. I mean, you must familiarize yourself into before getting into research. One way that I find most effective would be to find yourself a teacher or like an experienced researcher. This can be a lecturer from your university, or this can be a senior who's working or who's kind of have done some he has some past research experience. It can be a graduate student that is in Sri Lanka or outside of Sri Lanka. Now with the technology and the settings these days, most of the research meetings and all these collaborations happen online anyway, so you can make use of that as well. So the best thing would be to join an existing research group and work with an experienced researcher, because there will be a steep learning curve and you can learn a lot. So the things that will take years, if you do it by yourself, you can learn from one project to two projects if you work with someone experienced. You don't have to be like a in your first research project. You don't have to be the most contributing member of the group. You can just observe what's happening. You can contribute as much as you can, and then you can pick up from that. So all you have to do is reach out, and I'm sure most of the people who you reach out will be willing to include you in their research projects. And there are plenty of other programs like the Scholars program that are kind of try to pair young researchers with some experienced researchers. So there are programs like that out there. If you're interested, you can check those things out as well. All right. With that, let's wrap up the first part of the session today. And please do ask if you have any questions.
Thank you, Vinoj, for the very informative session so far. If there is anyone who wants to ask a question, they can either post them in the chat, either direct message or to everyone would do, or you can just unmute and ask. If you can raise your hand, and then I can refer to you. In the meantime, you can type your messages and send them in the chat. Or unmute and ask. Okay, so I think this is related to. I think this is partly related to the literature part that you mentioned. So when you mentioned about textbooks and all that as resources to learn by yourself, are there any certain authors that you find more particularly better than other resources? Like, if there are, then what are the writing techniques that they use, or the teaching techniques that they use in their books that appeal to you? Is it like the top-down approach, or like what kind of books do you recommend that is a good stepping stone for beginners or any other skill level?
Yes, that is actually a good question. So let me actually revisit that slide. So these are actually some of the books that I can actually recommend to you, and these are some of the books that I actually find better than other books. For example, I'll take an example. The rightmost one, the Deep Learning book by Ian Goodfellow. The 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 most interesting thing about this particular book and this set of authors, and Yoshua Bengio is an excellent author. If you like happen to follow his recent research work and all these things, the writing style is the books and the content are very comprehensive. Still, at the same time, they build from ground up. So they start from scratch. They don't assume that you know everything. I mean, a basic rudimentary understanding of some basic mathematics that almost everybody has. Maybe they'll assume that, but that's all that they assume, and they build from ground up. And if you read the book sequentially, then you will start to kind of realize and understand the core concepts first, and then they will gradually transition into some advanced concepts. So it's a good book if you are kind of at an introductory stage, or even if you are a very well experienced researcher. This is still a good book that everybody recommends. I think the deep learning book and the deep learning book by Goodfellow, the Boyd and Vanderberg, the convex optimization. So the convex optimization book might be, I mean, it might not be the most easiest to follow if you are not familiar with this convex optimization concepts at all. But still, it's a very good book, because all these books actually try to go from ground up. They try to start with the basic fundamental concepts. They move at very different paces. Like some move at a very rapid pace, and they move to different content at very rapid pace. But some books actually explain things a little bit more, like the deep learning book by Ian Goodfellow. But the beauty of books is that you can follow them at your own pace, so you can do some extra reading to catch up. And likewise, so these five books are five books that I actually prefer over some other other similar texts in the area. So I think these are like excellent books for those who want an introduction, or even if you are well versed already, to just refresh on certain things. These are like very good books.
Thank you. I think that answered the question. Next, I think you mentioned something about research papers that I found interesting. You mentioned how you have to not necessarily read 30 research papers and remember every single detail in them. As someone who is still an undergraduate, how do you keep up with your academics where you have to remember this enormous amount of information? It may or may not be enormous, but relatively, like to their level. And what do you say to people who at that level feel that they are sort of overwhelmed by the amount of information that they already have to study, but now they have resource space for their own interests? So especially this is something I think you have insight on, because you have so many. Uh, if you examine your CV, I think you have accolades in like numerous fields of study, like law and IT, all the while being very exceptionally successful in academics. So, why do you think you were so successful in managing all of that, which could seem overwhelming to some people?
Thank you for the question. So, well, um, it's kind of all about time management and setting your priorities right, and knowing what to let go at a given time. So, I mean, generally speaking, if you do multiple things, if you do multiple tasks at the same time, or if you multitask, um, you have to curate a list of priorities, and you have to carefully pick which, given the time constraint, which ones you have to focus on more, and you might have to eventually let go of a few things too. So you should learn to prioritize and learn to let go. So those are like two things that I kind of like follow even to this day, and I find effective. So when I say prioritize, say that you have uh, a few tasks, like a set of tasks, and then you have only a limited time to do, and then you kind of have to be smart about prioritizing what you want to do. And another thing that I find very helpful is, it doesn't matter if you are doing some task for like a very limited amount of time. So for example, let's say you have only 30 minutes to do a task that takes 1 hour. Still, if you focus really hard, and if you don't if you don't like distract yourself by the fact that you have less amount of time, you can still actually do a good job, like a productive amount of work. So what I'm trying to say is that, yeah, I understand that, like, if because of all the work that you have, and these days it must be like especially challenging as well because of the current situation. You might have extra restrictions as well, and even though you have these constraints and restrictions, if you actually do find some time, like, I mean, everybody, I mean, I believe in in the fact that no one is too busy. I mean, if you really are passionate about something, then you can definitely still find some time. The important thing is, whatever the little amount of time that you do find, do concentrate on whatever you are doing at the moment, without, like, if you, in your mind, if you try to switch between tasks too repeatedly, then you might not end up like getting anything done. So um, if you set your priorities and then pick something to do, and you do that, and you don't worry about what you could have been doing in that time, what you're missing actually. If I did the other tasks, could I have done better? No, I mean, just, if you maybe if you decided to let that go, maybe it's good to do that with no regrets. So you focus on this additional tasks, or whatever the little time that you can allocate, focus on that, um, on that task, and then you will actually do a very good job, uh, even with a limited time. So that's a kind of like master how to like be productive in a limited time. And yeah, so, and about the aspect where you already have a lot of information to deal with, and I've been in your shoes some couple of years ago, and I know how much information that you have to retain, even for exams and all this coursework. This is especially challenging, and if you plan to like take up research, then you need to allocate some capacity to that as well. So this is why this is exactly why I suggest um, keeping like a journal or like a summary version of that. So that you don't have to actually keep everything, retain all the information in your mind, and you don't have to keep reading the same thing over and over again. If you read it once, then summarize the important things. You can just, if you don't want to maintain journal, just you can just highlight it or write in the paper itself. And then this is a good way that you don't have to keep reading the paper over and over again. And if you go to some other task and you come back in a couple of days, you can still read your notes and read the summary, and then you can kind of understand it. So uh, yeah, I think if you're really passionate about something, then it's not very hard to find some time to do it, and you do it in a effective manner so that you don't waste additional time, but you concentrate and get most amount of the work.
Thank you. I think we have time for one more question. Uh, were there any other interests during your undergraduate period that you had? And if so, why did you choose AI, machine learning, and signal processing as? Why did you choose the fields that you did instead of these other interests?
Yeah, so yeah, that's actually a good question. So I initially, like most of you, did not have um, any certain like areas that I thought, okay, this is definitely going to be my area. I never had that coming into the university. I never had that even like um, during the, I think, not until the third year or close to the final year of university. So I believe in the approach of trying out everything that you are interested in and then picking, rather than like blindly picking something. If you if you feel like you have an interest in certain area, like you have to get your hands dirty on that area. So I have whatever the areas that I'm interested in, that I think that I have interest in, I have I have tried to do something. It's like robotics is something that I'm very passionate about, and I like telecommunication as well. So I have tried projects in telecommunication, and across all these things, having tried all these things, computer vision, AI, and machine learning, and these areas, and of course, signal processing always go hand in hand with them. Is These are the areas that most appeal to me. I um, and I was kind of persuaded by the type of um, projects that they have. So, for example, I showed you some of the existing, like some of the recent work in this area. So, and my intention was to kind of like persuade you into like exploring a little bit more into these projects. So I was kind of attracted by how interesting these things are. I'm not saying that robotics and all the other areas are not interesting, and I mean they're still very interesting, and I'm very passionate about all these areas that I did. But it's a very personal, subjective thing. I was um, these areas most this area of computer vision, AI, and machine learning, with along with signal processing, is the area that um, was most appealing to me, um, and I felt more satisfied by accomplishing research um, projects in these areas. So I decided that this would be the area to get into, and of course, the industrial opportunities and the opportunities that the things that you want to do after. Something that I wanted to touch during the second session as well is that um, you have to kind of you need to have a good profile, that's true, but you need to tailor make your profile to fit what you want to do after it. For example, if you want to join the industry after your undergraduate degree, you have to kind of tailor make your profile starting from these days, so that it looks very attractive to um, a recruiter in the industry. If you want to get into academia, then if you want to do graduate studies, then you have to kind of think beforehand and tailor make your profile to be appealing to a graduate admission committee. I mean, you can't start doing that at the last minute. It's not. It takes time to build a profile. So because you have to always think about your goals as well. Whatever the field that you pick, you have to always have the end goal in mind as well, and you have to know what's required. So if you go into the industry, you should know in that field, in the industry, what are the requirements, what are the standards that they maintain. So you have to kind of be aware of that beforehand, then try to build it. So when I did that for these areas of AI, computer vision, signal processing, I kind of saw the demand that they have. This is a very competitive area. At the same time, even if it's very competitive, it's very rewarding. So that's something that attracted me as well. The opportunities that this area has. Um, so my interests were well aligned, and also the opportunities were there. So this is something that I chose as my primary area of interest. But I still do have the other interest as well. I still follow up things in law. I still follow up things in robotics. I still follow up things in everything that I've done.
Thank you, Vinoj. I think that answered the questions well. Due to time constraints, we would have to move on with this session. So I would now like to hand control back over to Vinoj.
Hey, thank you. In this session, I would like to talk a bit about how to do well in machine learning and computer vision or signal processing research. And I want to talk a bit about, in general, what are the things that you have to keep in mind. So I'll get a start from uh, the last question that we were discussing, building your profile and then building a research profile. And I'll share some insights that I have. So as I was mentioning, you have to kind of pre-anticipate what is required from what you want to do next. For example, if you want to join the industry at some point, then you have to kind of know what is required from the industry, and then you have to tailor make your profile to that. So if you go into if you go into academics, then if you want to do graduate studies, then you have to kind of start thinking of what is required to get a good PhD admit or a good MSc admit from an early stage on. And research actually play a very critical role in that. If you actually do get into research, it doesn't matter which field it is. If you get into research at a very early stage, then it's going to be very helpful to you, because you can, by the end of your undergraduate career, or um, at the end of where you want to be, within the next 2 to 3 years, you will have a good amount of experience. You will be a well experienced researcher by the time. So when you come to the position where you want to join a PhD program or MSc program, or if you want to join the industry as an engineer, you don't have to spend time, first of all, by getting familiarized with these things again, because you are already well versed. At the same time, this is going to open a lot of doors for you. So when your profile, when you're strong, if you have already tailor-made your profile to fit what is required by the industry or the academia, then once they have your profile in hand, then they will be already kind of pre-impressed. Then you don't kind of have to spend a lot of time during your interviews or whatever you do afterwards trying to impress them. So this is something that is critical. So um, it doesn't really matter like what you want to do afterwards, but start whatever that you want to do. Start tailor making your profile to whatever you want to achieve, or whatever you want, whatever the opportunities that you want in the future. So having said that, now let's move a bit away from career-wise into machine learning, signal processing, deep learning kind of research areas. So now we know that we have to be familiar with coding. We know that we have to be familiar with theory. We know that we have to be well versed in the literature. But actually, how do we do this? I mean, one thing is, how do we come up with these kind of ideas? And ideation phase of research is actually one of the most challenging, or one of the most um, difficult phases of research. Once you have an idea, once you have a hypothesis, then you can keep working at it, because you already have um, an idea in mind. But coming up with an idea is just most challenging. So even the research papers that you might have already come across, or even the projects that we saw a while back, like some might wonder, like, how did even people come up with these kind of things? Do I have to come up with these things? And then it comes to the next question: do I have what it takes to come up with these kind of things? And do I have what it takes to like do research, do well in research? So my answer to the first question is, you don't have to come up with groundbreaking ideas from day one itself. A lot of the research that has been done in these areas are incremental research. So incremental research means you take an existing work and you try to make some aspects of the existing work a bit. So it can be the performance of it. So when I say performance, it can be the accuracy of it, or it can be the speed of it, or it can be that the system is more robust. So you take an existing system and you try to make an incremental change to it. You try to improve one or few aspects of that research. So this is known as incremental research. And most of the work, I think about 80% of the work, more than 80%, I would say, 80 to 85% of the work that is being published in these areas right now are incremental work. They take an existing work and they try to make an improvement. Or you take two or more existing systems and you try to merge them together and make them function. Or you take one system in one domain and you try to adopt it into a different domain. So these are incremental research changes. So incremental research is a good way to kind of get into research first, because you already have a baseline. You might already have some implementations. You already might have papers, and in the papers the authors may have described very well the theories and the challenges that you have to come that they faced and how they came over them. Um, you have some good reference points. So this is not to say that if you have a good idea, then don't work on it straight away, but please do. But it's mostly the case that most of us don't have an idea, like a good research idea. So we can always think of incremental change. So this is when you read papers, then you might think to yourself, okay, why did they do it this way? Why didn't they do it in this other way? If you do it in this other way, then you we might have like gotten a better performance, or we might have gotten ourselves around a bottleneck, and which might speed the process up. So these are kind of the incremental changes that you think to yourself that could have been done. I mean, we all do it when we read something. We all question in our minds, like, okay, why did they do it this way? Why didn't they do it in the other way? So these are like good entry points to incremental research. So once you start doing incremental research and once you get yourself familiarized with the research settings, the research process, mind you, from ideation to publication, there is a long way to go. So once you get yourself familiarized with it, then someday you will have some groundbreaking idea. Then um, you will have a research that will someday be regarded as a milestone contribution in the field. So, but that doesn't happen from day one, and it doesn't happen artificially as well. So if you kind of sit down one day and okay, say that okay, I'm going to come up with a groundbreaking idea now, that's never going to happen. The idea might hit you when you're reading some other paper, or when you're working at something else, or when you're having a conversation with someone about the topic. You never know. So it's okay if you don't have any research good ideas. Try to find something incremental to do. Incremental research is still very valuable research, and it helps the field progress as well, and you can get some publications out of it as well. So if you don't have good ideas, start thinking about incremental research and start thinking about some existing systems and start thinking about how to improve them. So then it comes when we can come to the next question. Do I actually have what it takes to do good in research? I mean, there are like thousands of researchers doing machine learning research, deep learning research, and computer vision research throughout the world. So how can I actually compete with them? So the the first answer that I have to give is you never know until you try, right? So I think it's rather than like trying to figure out actually um, whether this is something that can be done, or um, whether you have what it takes to do it. You can get into the field and try to see how it feels first. And we have a lot of examples from uh, Sri Lankan undergraduate students that have conquered the world stage. So we have a lot of papers already produced by our undergraduates at ICASP's conferences like CVPR, conferences like PACWI, and recently there were some good journal papers from University of Martua in a prestigious information theory journal. So these kind of work are being produced by um, undergraduates, our own undergraduates, our colleagues, and our juniors, our seniors. So our undergraduates do have the capability of competing in the world stage. So um, you can think of that as a very strong motivator, and you can aim to do some good solid research someday. And um, and some things that you have to keep in mind when you're doing research is that um, it's different from doing a project, some kind of like an engineering project or something like that. It differs in multiple ways, but the main way that it differs is that in research you don't have a clear objective, you don't have a clear goal, you don't see a clear end target from the onset. So you might start the research by thinking of doing something, but you might end up with doing completely something completely different. So the problem that most people have when they don't see a target, right? So if it's an engineering project, if you have to build something, then you kind of know, okay, this is the end product that we need, and all our efforts will be targeted that end. But in research, it's not the case. You do have some hypotheses, you do have some objectives, but they keep changing all the time. So you are the one who is actually um, defining what you want to do and how you do it. And most often than not, you are attempting something that no one else has done before. So this can be pretty challenging sometimes because you can get stuck um, for a long time on a certain problem, or you simply don't know how to proceed from there. This kind of. So in these situations, don't be hesitant to reach out to someone who's uh, someone you think more experienced. So for instance, you can talk to a lecturer at your department, or you can talk to a senior who has worked on the problem. So the most important thing is that you don't try to um, sort of reinvent the wheel. So I'm pretty sure that most of these questions that you face when you're doing research, somebody else who has done the same, who has tackled the same problem, or has been in the same shoes, have already encountered and already figured it out. So don't hesitate to reach out for help, because it's reaching out for help and talking to people. It's very helpful for you to not only solve your problems, or but also to have a better understanding of a problem coming from different perspectives. So someone else might have a different perspective of the problem, and you can see things in a new light if you talk to them. So fun. Based on that point, I would like to come to some final remarks. So in research, one of the most critical things is collaboration and networking. So it's we are living in a in an age where like it's things are like knowledge is being produced at a rapid pace every day from every parts of the world, especially in computer vision, machine learning, deep learning, signal processing. These are very fast moving fields. So you see tons of new work being done every day. So to keep up with all this, you need to have collaborations. You cannot work on research problems by yourself. I mean, um, if you have uh, if you even if you have the capability of doing the research by yourself, it's always a good idea to talk to others. They might have um, seen things from a different perspective that you might not, or they might have encountered a similar paper that you might have missed or something. So it is very important to collaborate as much as you can. Uh, you can collaborate with your peers, you can collaborate with your seniors, you can just collaborate with anyone who presents you with the opportunity. And I'm sure like most researchers, almost all the researchers are willing to contribute, collaborate with others, and it's a must. It is becoming a necessity in research. And also networking. Network is vital. Um, in research, you can open a lot of doors for you if you network well. So talk to other researchers, attend talks by different researchers. I mean, one great advantage of I mean, pandemic is very unfortunate, but one silver lining of that is that a lot of conferences are happening in a hybrid format, where the in-person conference is happening. Also, there is an online version. So the advantage is that you can register to these conferences and you can attend these conferences and listen to the talks and network with other researchers as well. And you can do it for a cheaper price as well. So there is usually conferences have an enormous price tag. You have to take care of travel, accommodation, and then you have an enormous amount of registration. But in the hybrid format, if you attend virtually, then the registration, you only have to pay registration, which is mostly around $50 or even less than that. So take take this opportunity. The hybrid format, I don't know how long it will last, but seize this opportunity, see what's out there, attend talks, and see what other researchers are doing and see how they are doing it, and also try to network with other researchers from all around the world as much as we can. Um, yeah. So with that, I would like to move to the next Q&A session that we have.
Thank you, Vinoj. Again, if there is any question, you can either type it in the chat or raise your hand and ask the question. Due to time constraints, I think if you can uh, as early as possible, I think that would give you a better opportunity of asking questions. So please don't hesitate to type in the chat or raise your hand. My booster stayed back in the case in the country. I think
Um, Sorry, I didn't catch that question. I think there was a network lag. Would you be able to repeat that, please?
I think Ushan lost the connection from it. Um, so he was asking, like, compared to the time when you entered uh, computation area, and like looking at it now, what sort of great changes have you seen? Like from the at the time you entered in, maybe it was very different. Like, what's your feel about that?
Yeah, so that's a very good question. So, computer vision specifically is a field that is changing rapidly. It changes so rapidly, and we talk about papers that came in early 2020 as ancient papers. So, if you are already um, basing your work on a paper that came in 2020, which is not that long ago, then you most probably will be looking at a paper that's outdated. So that's how rapidly the computer vision field is changing. So the landscape of computer vision is very different from very different when I entered than now. For example, a key change is that now vision is the age of transformers and self-attention, whereas when I entered the field, it was the age of CNNs. So the CNNs were well established back then, and CNNs dominated everything. Um, um, this is back in 2015. So transformers were just on the onset. It was just an idea that was in NLP at the time. But now transformers and different few different things like transformers, nerve kind of things, which is neural radiance fields. These things are like dominating the computer vision arena. So there is a complete transition of ages during a short span of like 5 to 6 or maybe 7 years. Um, and Yeah, so I saw the transition from the age of CNNs to the age of transformers. And in another 3 years or another 4 years, the age of transformers will be over. That's unfortunately will be the case. It's bound to happen. Then there will be a completely a new thing that no one even imagined of until now. So that's computer vision is a rapidly changing field. So one disadvantage of um, this is there is always the risk of someone beating you to the punch, especially if you're working on a hot topic these days, like transformers or nerve or some hot applications like um, uh, the diffusion models, the DALI 2 that it was showing you. So if you actually work in these kind of topics, then you have to be very fast. You can't take more than like 6 7 months to get your idea out into publication. Otherwise, there is the risk of someone beating you to the punch. So that's very challenging. I mean, it's not always possible to do a research in 6 7 months. But this is why you need collaborations. You need to have a good a diverse team with a lot of hands at your disposal. You need someone to do the literature review. You need someone to produce results. You need someone to run experiments. You need someone to like do something else. You need all the help that you can get to do something in a short time. So that is big collaboration, and especially collaborating with like very experienced people is very important, especially in this field. So yeah, to answer your question, yeah, the field was very different. The landscape was very different. I saw an age transition, and yeah, it's we are expecting this trend to like even escalate more. Yeah.
Okay. One more question now from my end. What's your view on this? So there are a lot of companies based on natural language processing, like big language models. So there's like a huge potential in that area. So what's your view? Like, what could be the future with these language models being dominant, even in applied work as well?
Right. These days, BERT, GPT-3, Clip, those things are like very becoming very popular. So BERT and GPT-3 are um, like buzzing these days in terms of language models. But the problem is again like referring back to uh, the pace that this field is moving. We are not sure like when someone else is going to like put out like a completely new idea, or it can be an improvement on the idea, but it's like completely changing the landscape of language models. So there are a lot of like big companies like Google, Facebook, Amazon, working on these kind of topics. Even Facebook, um, um, Netflix, and those kind of companies as well, working on these kind of big language models. They are throwing a lot of resources at them. They are throwing a lot of data at them, and they have a huge amount of resources at their disposal. So you never know when there will be like a groundbreaking revelation that's happening, and it's bound to happen anytime soon, sometime soon. But still, I think BERT, GPT-3 kind of models kind of established. So a lot of like, at least, if even if the research uh, frontiers are moving so fast, the engineering side um, it's not moving that fast, because first, the engineers in the engineering side will adopt these things, and then they will move into production, and they will stay a while in production. So I think a lot of applications, industrial applications, focus still on like GPT models, BERT kind of things. So and if especially vision and NLP related things use a lot of clip. Even most recent papers use clip, so clip based models. So these things, like, even though the research frontiers will move fast, um, it will like move to something else. Still, these things will have some merit for some time to come, but not very long.
I see. Thank you very much for the insights.
I think due to the time constraints, we have to end the Q&A session there. Thank you very much, Vinoj, for the informative and insightful session. Not only did your presentation include a comprehensive view about your fields of expertise, how research and self-learning should be approached, but your valuable advice, I think, extends to the formula for a successful life in general. So I want to thank you for that incredibly productive session. Next, I would like to invite Dr. Chamire Dusuria to address the session.
Okay, so good evening to everyone, and I hope that you could hear me. And I will make a very short speech because I am currently recovering from dengue. And so, basically, first, I would like to thank our guest speaker, Vinoj. Actually, he's one of my past students, for sharing his views on the current trends in the machine learning, as well as some concepts related to the signal processing. Also, I would like to thank Signal Processing Society Student Branch Chapter at the University of Moratuwa for organizing these events. And this kind of events will be really useful for the undergraduates in order to have enhance their knowledge on the what's happening in the recent research, as well as how they can modify or how they can plan their careers beyond the undergraduate work. So again, I would like to thank Vinoj, and thank you for joining all of you, and have a good night to everyone.
Thank you very much, sir, and I wish you a speedy recovery as well. It's very
Thank you so much. Thank you.
Yeah. And thank you for this opportunity as well. I really appreciate it.
Thank you. And with that, I think we have reached the conclusion of the SPS Record, the second session of the series. Thank you all for joining. And I think everyone here has obtained more valuable information and insight about the the research areas and the technical details, and also to have a more successful academic career. And so with that, I think we can conclude the session. So thank you everyone for joining, and we will see you in the next session.
Yeah. And I wish you best of luck for everybody, for whatever the endeavors yet to come. And feel free to reach out if you have any questions about regarding anything. You can reach me at my email, or you can reach me in social media as well. And best of luck to everybody.
Thank you, Vinoj. And with that, we can conclude the session. So everyone, good night, and we will meet you in the next session.